What are adjacent angles? If you look at these two diagrams or figures, then you can see that we have two angles in each of these two cases, angle 1 and angle 2. Now, angle 1 is angle RQS. Angle 1 is equal to angle RQS. That is, we have represented angle RQS as angle 1. And angle 2 is actually angle PQR. Angle PQR. You notice one thing, that in angle 1 and angle 2, this is a common vertex for these two angles. Q is here and Q is here. Okay. Let me use some different color. This particular arm, this one, is actually what? Is the common arm, right? Common vertex, common arm, and the non-common arms, that is this QP, arm QP, and this arm QS. These are what? Non-common arms. The two non-common arms are on the either side of this common arm. This QP is on this side and this non-common arm QS is on this side to QR. So QR is a common arm, QP and QS are two non-common arms, and the two non-common arms are actually on the either side of the common arm. So three conditions it should satisfy. The two angles should satisfy in order to be adjacent angles. That is, they should have a common vertex, like in this case Q. They should have a common arm, like in this case QR, and the two non-common arms should be on the either side of the common arm. So the common arm will lie in between the two non-common arms. Same thing you can see here. First, check what's angle 1. Angle 1 is CBD. Angle 2 is angle ABC. Of course, the common vertex is this one. This condition is satisfied. The common arm is actually this one, right? So this condition is also satisfied, and the two non-common arms in this case is actually what? Arm BA, that is this one, and arm BD. These two are two non-common arms, and these two non-common arms, that is this one and this one, lie on the either side of this non-common arm. So even this condition is also satisfied. It means that this is also, these two angles, angle 1 and angle 2, are adjacent angles. Okay. Now, this was the three conditions that two adjacent angles should satisfy. One important point, we know that if we have an angle, let's say we have an angle, let's say it is QRS. If we take one point here, let's say this is A, this is B, this is C, this is D, then these A, B, C, D, we'll say that these are actually what? Interior points. These are interior points. And if we take point T, U, V, what next? G or H. These are G, HUTV, these are actually what? Exterior points, right? So interior points and exterior points to a given angle, that is angle QRS. So in these two adjacent angles, that is angle 1 and angle 2, and in this case angle 1 and angle 2, there will be no common interior point. There will be no common interior point. Why? Because these two angles are separate, though they have common vertex and common arm. But let's say that if there is an interior point here, this point, let's say it is T, it is exterior to this one, and if we take an interior point here, that is U, this U is interior to this angle 1, but this U is exterior to this angle 2. So this point is very important, that is, in two adjacent angles there can't be any common interior point. Okay, you have to tell whether, okay, here numbering is wrong, I'm sorry for this. This is 4, this is 5. Okay, you have to tell whether the given angles, that is angle 1 and angle 2, are adjacent angles or not. Okay, angle 1 is CBD, angle 2 is angle BABC. Now clearly B is the common vertex and BC is the common arm. The two non-common arms, that is arm BA is on this side of this common arm and arm BD is on this side of this common arm. Three conditions satisfied, yes, these two angles, that is angles 1 and angle 2, are adjacent angles. In this angle, those two angles, angle ABD is angle 1 and angle, okay, I have forgotten here, I should put a point here. Let's say this is Q. Okay, so in this angle, angle 1 and angle 2, can you see that are these two adjacent angles? Well, no, because this angle 2 is being made by CQA, that is, even if this point was not given to you, let's say that in this question no intersecting point has been given to you, even then you will assume that let it be a Q, point Q. Of course, for angle 1 this is the vertex, middle vertex, and for angle 2 this is the middle vertex, so there is no point that they will be having a common vertex, right? There is no point. So the very first condition, is not fulfilled in this case, that is, they should have a common vertex. We don't have any common vertex, that's why there's no need to further proceed to check for other conditions. This is angle 1 and angle 2 are not adjacent angles. In this angle, in this diagram, angle 1 is angle SQT, and angle 2 is angle RQT, SQT and RQT. Now one will say that this is angle 1 and angle 2, there is a common vertex, yes, the common vertex is there, but there is no common arm. There is no common arm. Why? Because this angle SQ and T is this one, SQT is this one, and angle RQT is this one. So we know that the common arm should lie between the two non-common arms, right? So in this case, this arm QT is not lying between, even if this arm QT is a common arm, because angle SQT and angle RQT, in this case this is a common arm, but it's not lying in between the two non-common arms. The two non-common arms are SQ and QR. QS and QR, these two are QS and QR. These two are non-common arms, and we know that the third condition is that the two non-common arms should be on the either side, of the common arm. So both these two common arms are actually on only this side, right? QS is here and QR is here, so there is no way that the two non-common arms are actually on the either side. Okay. What about this one? In this case, we have angle PTQ, that is angle 1, and angle STR or RTS is angle 2. Are these two adjacent angles? Well, you will say that yes, they are having a common vertex, that is T is the common vertex. First condition gets satisfied. What about the common arms? Well, in this case, we don't have any common arm. This is angle 1 and this is angle 2. There is no way that we can have common arm. So these two angles, angle 1 and angle 2, are not adjacent angles. What about this one? In this case, this is angle 1 SQT. This is angle 2 PQR. Yes, they have common vertex, that is Q. But do they have any common arm? No, they don't have any common arm because SQT and RQP are completely separate angles without having any common arm. So the angle 1 and angle 2 are not adjacent angles. Okay. Can two adjacent angles be complementary? Well, if you have, let's say you have two adjacent angles that are, let's take this diagram. So okay, let's say that this is A, B, C and D. Let's suppose that this angle 1 is equal to 30 degree, and this angle ABC, this one, that is angle 2, is equal to 60 degree. So are these two angles adjacent angles? Yes, they are adjacent angles. And are they complementary? Yes, they are complementary, because we know that the condition for complementary angles is that the sum of the angles should be equal to 90 degree. In this case, you have 60 degree plus 30 degree, and this is equal to 90 degree. So this is one of the example that shows that yes, two adjacent angles can be complementary. Can two adjacent angles be supplementary? That's really very simple. You can take another example. Let's take this diagram and this one. So if we have A, B, C and D, this is angle, let's say this is angle 1 and it is equal to angle 120 degree, and this angle is angle 2, that is equal to 60 degree. Okay, let's say this is 60 degree. It's not very accurately 60 degree and 130 degree, but just let's assume. So two adjacent angles be supplementary. We know that these two angles are actually adjacent because B is the common vertex, BC is the common arm, and the two non-common arms that are BA and BD lie on the either side of the common arm. Therefore, yes, these two angles are adjacent angles and their sum is 120 degree plus 60 degree is equal to 180 degree. Yes, these are actually supplementary. What about the third one? The third one says that two obtuse angles be adjacent angles. Two obtuse angles be adjacent angles. That's very simple. Let's take this angle. Let's say that this is angle A, B, C. This is angle 1 is equal to 110 degree. Let's suppose it is equal to 110 degree. And if I make another angle to this one, same color, let's say that it's something like this one. Okay. So if even this angle, now let's say that this is 110 degree and let's say that this is 130 degree or 140 degree, anything, this angle. I'll have to remove this one. So the vertex B is here. Let's say that this angle is angle 2 is, let's say, is actually angle 2 is around 150 degree, let's say. Okay, so this B is a common vertex, this B is a common vertex, and what's the common arm? The common arm will be, in this case, this one. This is the common arm, that is BC is the common arm, and the two non-common arms, that are BD and BA, lie on the either side of this common arm. So we have two obtuse angles, one is 110 degree and let's suppose the next one is 150 degree. Not very accurate figure, but just assume that. So we can see that these are actually two adjacent angles, angle 1 and angle 2, and yes, they two obtuse angles can be adjacent angles. What about this one, D? An acute angle be adjacent to an obtuse angle. That's very simple. If I take this angle, so if this is the condition, okay, let's say that this is A, B, C and D. This is angle 1, this is equal to 120 degree, and this is angle 2, that is, let's say, 60 degree. So, and these two angles, one is obtuse, one is acute, are adjacent. Yes, they are adjacent, and since they are having common vertex, BC is a common arm. The two non-common arms are on the either side of this common arm. That makes them adjacent angles. So yes, an acute angle can be adjacent to an obtuse angle, as we have seen here.